All right. I'm Monty Bain, the Southeast Regional Communications Manager, and I cover Florida to Virginia. And just to let y'all know a little bit about the Cotton Research and Promotion Program, it's three-layered. The Cotton Board collects the assessments, administers, and communicates to the stakeholders. Cotton Incorporated does all the research. They promote, and they create demand and profitability, and the USDA governs the program. Your Cotton Board assessments is $1 plus 0.5% of the value of the bale at the first sale. You have producer and importer assessments, and the importers came on in the early 90s. You see there on the screen that producers pay 53% thereabouts, and importers about 47%. And we collect well over 99%. There's maybe one person we miss, but we do our best to collect it all. Our budget for 2021 is $80 million. That's down from $86 million in 2020. Okay, our state support program. Every state gets 7.5% that is collected in the assessments. It goes back to localized research projects, and that's based on each state's production. And you'll see in a slide coming up that Georgia gets more than Alabama. Alabama gets more than Florida, and that's based on production. And the funding is determined by what we call state support committees. And each state has a group of cotton producers that go in and meet and vote on which projects that are the most important to them. And we have Cotton Board and Cotton Incorporated board members and researchers and CPOs on those state support committees. Cotton research projects are managed by Cotton Incorporated's Ag Research staff member. And in this case, it's Don Jones, who covers Georgia, Alabama, and Florida. I just wanted to point out some of the industry partners and leadership we have. You can see on the screen that Alabama has Jimmy Sanford, chairman of the State Support Committee, and Ricky Wiggins is chairman of the Alabama Cotton Commission. Jerry Davis wears two hats. He's chairman of the State Support Committee in Florida, and he's also Cotton Incorporated's Ag Research chairman. David DeFelix is a Cotton Board member, and he's also the Cotton Board chairman of the Ag Research Committee. And Jamie Geralds is the Florida Farm Bureau liaison for cotton. Bart Davis is chairman of the State Support Committee for Georgia. Taylor Seals is the Georgia Cotton Commission executive director. And you guys have got wonderful representation in the Southeast. Jimmy Webb is the current chairman of the Cotton Board from Georgia. Van Murphy is the current chairman of Cotton Incorporated from Georgia. And Kent Fountain is the current chairman of the National Cotton Council from Georgia. Also not on this screen is Dave Rupenecker with the Southern Cotton Growers, and Rusty Darby, who's also a Cotton Board member, is the current chair for the Southern Cotton Growers. There's several others, but too many to mention are put on the slide. Thanks for all of y'all that serve on these committees. Next slide. And with that, we're all over social media, or you can contact me at mbain@cottonboard.org, or text or call me on my cell. I'll try to answer any questions you have. And at this time, I want to introduce Dr. Don Jones, Director of Breeding and Genetics at Cotton Incorporated. Also on the panel will be Steve Brown, Extension Cotton Agronomist at Auburn University, and Dr. Cater Hake, Vice President of Ag Research at Cotton Incorporated. And Don, it's all yours.
Thank you, Monty. As Monty said, my name's Don Jones. I head the breeding and genetics areas, and I'm the state liaison for the Alabama, Florida, and Georgia growing regions. The map on the lower right-hand side shows you the acreage of those counties where cotton is grown in those 3 states. You can advance the slide. As Monty mentioned, the dollar amounts for each state vary. In the upper left-hand corner is the individual breakdown for each of the states. Again, this is 2020, or the last year's state support funding. These dollar amounts do not include core funding that's allocated by Cotton Incorporated. It also does not include Alabama Cotton Commission funds that are overseen by Jimmy Sanford. And likewise in Georgia, there's also Georgia Cotton Commission funds that are not included in the above figure, and that's overseen by Taylor Sills. If you look at the graph on the far right-hand side here, it shows the 3 states. Obviously, as Monty mentioned, Florida has less acreage and they get less money, but the bottom line is Florida, the middle line is Alabama, and the top line is Georgia. You see that yellow box, the dollars are figured from a moving 5-year average. And so the 2020 dollars come from 14 through 19, and they drop the low and highest. And so in essence, it's an average of 3 years, dropping the lowest and highest. You can advance. The agricultural staff that I work alongside, in a few minutes, Dr. Cater Hake will speak. He's the vice president of the department. He's also been handling the pathology or the disease program for the last 6 or 7 months. Also, our newest staff member is Dr. Galen Morgan. He handles weeds and soil health. The picture that's kind of faded on disease and fertility, many of you all knew Bob Nichols. He unfortunately passed away last October. He handled the disease and fertility and nematode work. Dr. Ed Barnes handles ag engineering. Dr. Ryan Kurtz handles entomology. Tom Wiedegardner handles cottonseed, and I handle the breeding and genetics areas. And each of these people handle different states across the country as the state support liaison as well. You can advance. From here on, Dr. Steve Brown, a longtime faculty member, first off, I should mention, we have online resources regarding the state support program. The top is a link. This will be available afterwards, so you don't have to write this out right now, but the link at the top describes and summarizes what the state support program is. And the one at the bottom where it says grower focused information is called Cotton Cultivated. It's a website where much of our research that's grower focused and written in grower language is highlighted. And then if you have any questions for me, follow up, my email is listed at the bottom. It's fairly easy. You can now advance. The following speaker is Dr. Steve Brown, and he will cover individual projects in each of the 3 states mentioned. Thank you all for attending today.
Thank you, Don. It's going to be a challenge to represent all that we want to talk about, so I'm going to hopefully do it in a very timely fashion. But first up, as you see listed here, is Dr. Kathy Lawrence at Auburn. Her focus is root knot and reniform nematode management. Her root knot studies are in central Alabama near Shorter at the plant breeding unit, which is a site that's been a focus of study for maybe 40 or 50 years. And reniform studies are at Belmont. But in terms of root knot, she's looked at in-furrow and foliar programs, and in one study she had resistant and susceptible varieties, and she follows up with root knot counts, egg counts, and then of course measures yields. And she sees increases in yields and decreases in egg counts where she imposes different treatments. And in a second trial, she explored in-furrow fungus materials plus foliar nematicides, along with some aggressive foliar fertilization. And she did see the best yields that included all three, that is the in-furrow treatments, the foliar biodate treatment, as well as foliar fertilizer. In terms of reniform, she has some sites at the Tennessee Valley Station that have intense pressure. And in one study, she had multiple varieties with and without vellum total. And the nematicide increased yields by about 280 pounds. And then in other multiple treatments, I think she had five trials on reniform nematodes. She looked at seed treatments and for nematicides, foliar biodate. And again, under heavy pressure, she did see significant effects in terms of growth. She reduced reniform egg counts and yields. She also has done some work with resistant varieties with and without nematicides. And she sees that significant or consistent trend, not always statistical, but significant improvements in yields, as well as reductions in reniform egg counts. I might also add, it's not shown here, but she has a verticillium wilt site in Northeast Alabama. At one site, she tested 20 varieties and saw a 37% reduction in yield due to vert wilt. And she did identify 5 varieties that seemed to be more productive in this verticillium wilt site. One thing that's not listed there is her, and is not reported per se, but her graduate student program is beyond excellence, and she's turned out some fabulous students. So that's part of what your grant dollars support. The second area is studies that I'm responsible for. It's an umbrella approach. One area of investigation is on-farm variety trials, which of course is done in Georgia as well as in Alabama. We try to supplement the OVT type research. As we move forward in 2021, we hope to take the set of varieties that will be tested north and south and subject them to a plant growth regulator regime to kind of get an assessment of how different varieties respond. A second area of trial was seeding rates. How low can we go? We had trials at Bruton and Headland in 2020, and we tested seeding rates between 1 and 3 seed per foot. And our aim was to deliver 1 seed every 4, 5, 6, 7, 8, 10, and 12 inches. And I just summarize, say overall, we saw very, very few differences in plant growth. And then more important, we didn't see a whole lot of differences in yields regardless of our population. A third area of investigation is what I term seed handling. And I've always thought, do we damage seed at the warehouse, or do we damage it on farm by how we throw it around and expose it to heat? And so we did a very simple study where we took seed and we dropped it multiple times on a gravel drive from a height of 7 feet. Then we exposed it on a truck mat for 6 hours in full sun, and it got to a temperature of 140 degrees. We then we planted those seed at 3 different locations in the state. In terms of growth, seedling growth, stand counts, didn't see a whole lot of difference. We did at times think the heat exposure actually improved growth, but it didn't always reflect that in our data. Yield-wise, we did see one location where our dropping the seed reduced yield somewhat. Another area of study has been a seed quality project. It's a belt-wide program in which we swap seed with growers, and we tried to compare company data versus that with data generated from the North Carolina Department of Ag. Many of you are aware of the issues that North Carolina has seen on seed quality. I'll just say my site was probably unique. I had 7 varieties from growers, 4 came from plot seed, and 1 came from Texas, so Texas A&M. In my particular trial, the variety, and I had 5 lots of it that had the least seed quality measured by warm and cool germ, as well as early season fresh weights, the poorest had the best overall yield. Now, my situation was planted in very, very good conditions, so seed quality really didn't make a difference. It mattered more about genetics. Another area of investigation was row spacing. We're playing outside the box and looked at 48-inch rows at both Bruton and Headland, and really saw no difference in yields at either location with 48 versus 36 inches. One final area, I tried to do a study in which I asked the question, is bronze wilt a function of the cotton leaf roll dwarf virus? I didn't have good infection, so I didn't get a whole lot of answers there. Let's go to the next slide. Okay, the Florida projects. Let me say in 2019, my coworker, Dr. Jenny Kobernick here, a breeder, she coerced cooperators across the U.S. to plant what was called a sentinel plot on the cotton leaf roll dwarf virus. They did it basically as an observation type approach. We provided 6 varieties. 2 were from Brazil that had shown some resistance to their blue disease there. And cooperators sort of did it gratis and just as an observation type approach. We repeated that same program in 2020, but a lot of the Florida funds were focused to help ramp up investigations in the cotton leaf roll dwarf virus. This was sort of an idea and project spearheaded by Dr. Bob Nichols, where scientists from the 5 states that you see listed took very aggressive sampling and measurements, 30, 60, 90, and 120 days. They counted aphids. They checked symptomatic and asymptomatic with PCR, which is a very expensive process. So that's where a lot of support dollars go to. And I'll just kind of summarize. Well, let me say some of these were multiple sites, some exposed and looked at planting dates. Dr. Jeremy Green in South Carolina looked at aggressive aphid management and sprayed maybe 8 times and couldn't zero out aphids and couldn't really change yields and didn't really have an impact on the virus. I will say, if you look at the big picture, incidence in 2020 tended to be less than in 2019. Also, incidence was less as you go north. It was greater problems on the more southerly areas of the belt, and certainly Alabama and maybe Georgia as well. But there's still not full agreement on symptoms and expression. The virologists across the belt and certainly including in Georgia and Alabama do agree that this is probably a single virus that probably established initially in Alabama, but it now is found throughout the Cotton Belt, really from Texas to Virginia, and then also if you go north, south, Florida to Arkansas. It does seem that the occurrence and impact were less in 2020 than in previous years, but we still see a few fields that are in which disastrous effects occur. And we really don't understand the science of why that is. And so that's an area of continued interest and focus and research. So next slide, please. As we look at I'm going to move to the Georgia projects on the next slide, I hope. Thank you. But on this topic, on the topic of cotton leaf roll dwarf virus, before I move to talk about some of the highlighted Georgia projects, I really wanted to mention the research of Dr. Ping Chi and Jenny Kobernick at UGA and at Auburn, respectively. Ping's work, as you see in this slide, he has a lot of interest in promoting and developing root knot resistance. Dr. Andy Patterson, who's a genomicist at Athens, has done some work to show that our commercial varieties that we plant, we're looking at a very narrow germplasm base. And so his work assists Ping Chi's work to hopefully expand and diversify our gene pool of cotton cultivars. But both Dr. Chi and Dr. Kobernick have also contributed a great amount to the leaf roll dwarf virus. Both are looking and cooperating and collaborating together on looking for resistance within the cotton germplasm to cotton leaf roll dwarf virus. So I wanted to make that point. The first highlighted study is Dr. Greg Payne, who is a scientist at the University of West Georgia. Insecticide resistance has long been a challenge and recognized. And so particularly on corn earworm and tobacco budworm. And where we stand and where we're going, where we've been is an important measurement of the tools that we might use. And his work, this is an ongoing project, a lab project where he's involved. In 2020, he actually, I think, collected 14 sites where he had corn earworm collections, and then 2 sites where he had tobacco budworms. And then in the lab, he exposed those worms to a pyrethroid, to the insecticide tracer or spinedoram, and to Cry1AC, which is the original gene in the first Bollgard cotton. And what basic conclusion is that, yes, we see significant resistance to Cry1AC, but not to tracer. And the pyrethroids still maintain their effectiveness in the lower southeast. This is really a contrast to maybe what other parts of the belt report, but our entomologists in Georgia and Alabama continue to support the conclusion that we can, until proven differently, that we can continue to use the pyrethroids to address escaped worms in BT cotton. Another area, next area highlighted is Dr. Stanley Culpepper's work. In 2020, he had 48 different trials looking at Palmer amaranth resistance and the various things that surround it. One area of significant, I think, help at the grower community is, and we'll see this moving forward, is looking at drift reducing agents as terms of formulations, particularly associated with dicamba. It does seem to help address some of the volatility issues. Another area of study from Dr. Culpepper has been reduced grass control when you have dicamba glyphosate combinations, and maybe there's some things you do in terms of timing. A third area would be his cover crop work, where he shows significant reduction in Palmer amaranth establishment in heavy cover. But then how does that intersect with different pre-emergence herbicides? And he shows that, yes, it can work. And he reports on the different herbicides that he's used. Another area of his effort is when we can use the chlorocetamide herbicide Warrant, which is a controlled release product. We can use it pre in cotton, where we can't use products like Dual or Outlook pre. But then if we have to replant, how do we manage that? And there's some timing issues that he's demonstrated there. Another area he's working in is something on the horizon, and that is a new herbicide resistance technology called HPPD. And that may be something that we see in the coming years. And of course, he enfolds all this together to aid in his Using Pesticides Wisely training program, which has been a very valuable learning program for farmers, and it shows in the reduced issues of off-target movement in the state of Georgia. Moving on to the next project, Dr. Charlie Lee at Athens, he's an ag engineer, and he wanted to try to develop means of counting blooms and bolls with a sort of a remote sensing type program. And what he did, he equipped a machine with cameras, video, as well as instant moment cameras. And in 2020, he sampled about 80 plots. And again, the question is, can we accurately remotely count blooms in a real-time fashion? And his approach was about 90% accurate over the season. It was a little challenged at peak bloom because of vegetative interference on the blooms lower in the canopy. The next area is Dr. Wes Porter, who's an ag engineer at Tifton with UGA. He's evaluated the effects of planting depth and planter downforce pressure on emergence, and he used 2 different varieties, one large and one small seeded. And really what he was looking at was seedling vigor. And his planting depths were 1/2, 1 and 1.5 inches. And at the shallowest depth, he really got a very poor stand. He got about 20% stand in that setting, but about 65% at the others. Generally, the low vigor variety had lower percent emergence, which is what you'd expect. but yields tended to be higher at the more shallow depths and with the least downforce. He actually did see even, and this was a surprise, I think he saw even where he had poor stands, he made some excellent cotton yields. So that's Dr. Porter's work, and he's got another project on here as well. Another area in the agronomic and physiology project or effort is from Dr. John Snyder, who's in Tipton. And he asked the question, because seed concentrate protein and nitrogen, is it possible that we could determine our nitrogen rate based on seed characteristics? So he conducted a detailed analysis of seed and then plant growth and yield and all those components. He really, his first year out, he got comparable yields with the largest seeded and the smallest seeded. So he really didn't get it what he was about, but he did a tremendous amount of work, and it probably is going to provide some very good information about where nitrogen partitions in the plant. He did indicate a trend towards increasing yields with increasing nitrogen rate. In 2020, the zero plot, of course, had the lowest yields, but in 19 had the lowest yields. In 2020, the yields were much higher, and he tended to see the highest yields at the higher end rates, which were up to 125 and 150 pounds. So again, he didn't answer his great quest, but he did, I think, provide some information that shows where nitrogen goes in the plant and maybe how we might adjust rates and think about rates. Moving on to Dr. Chad Patton. This is outside the box. He's a food scientist at UGA. He wanted to explore cottonseed oil as a remedy for non-alcoholic fatty liver disease, for which there currently is no approved treatment. And the disease is an umbrella term for a condition in which elevated fat stores in the liver, and it concentrates in the liver. And as the name implies, it's not alcohol related. It is more common in the Western world than anywhere else, and now is the most common chronic liver disease in the US. And then in its most aggressive form, it can lead to inflammation and cirrhosis, which cirrhosis means injury, scarring, and it's a loss of function. And similar to what happens with excessive and prolonged alcohol use. But what he identified was a lipid compound, a fat compound called DHSA, that may limit or displace the storage or the buildup of fat in the liver, and therefore improve human metabolism and help address this emerging condition of non-alcoholic fatty liver disease. So that's an outside the box type project that has some real interest. Another area is Dr. George Velitis' work. He's an ag engineer in Auburn. He did his studies at the Stripling Irrigation Park, and his goal was to try to explore the efficiency of irrigation and fertility. He was looking specifically at nitrogen and water use efficiency. His treatments were a typical approach of fertility, and then he used fertility based on what's NDVI, which is normalized difference vegetative index. Basically, he's trying with a remote sensing device, he's overlooking the crop and determining how green it is, and from how green it is, how much nitrogen you put on. He also compared that additional treatment. He had a fertigation type approach where he spoon fed the crop through the irrigation. And so his efforts do show that there is a possibility of altering or managing our nitrogen as we take a remote vegetative index of color and sense that from an aerial means. And then finally, but certainly not least, Dr. Sadiq Bagg is a virologist at Tipton at UGA, and he's been clearly one of the leaders on the cotton leaf roll dwarf virus issue. He's done a significant amount of work to improve our detection methods and our tools, and to explore the basic science behind it, including what is the genetic makeup of this? Can we develop infectious clones, which is simply a way to facilitate research in a more easy fashion. Testing, as many of you know, and you hear this about the human virus as well, it involves PCR, which is I can spell that, but it is it's polymerase chain reaction, which is, it looks at the genetic makeup of whatever you're trying to assess, the DNA or whatever. It confirms the presence or the absence of the virus. And in the case of CLRDV, a sample costs $30 an acre, $30 a sample. So Dr. Sadiq has tried to develop a quick management tool. I think he was disappointed in how good it was, but he's again exploring a quick test that would really help us to get further down the road in a more economical fashion. But he's also done some excellent work on categorizing the symptoms pictorially and otherwise. And then he's tested a lot of weeds and looked at what's out in the environment. He's obviously assisting Dr. Payne in terms of genetic assessment and looking at lines. And he and Dr. Cassie Connor here at Auburn, they collaborate very well and exchange information. I really do view Sadiq as a leader in the cotton leaf roll dwarf virus effort. So that concludes what I've done, and I hope I haven't maligned anybody too badly, but I'll take questions at the end maybe. I'll turn it over to Dr. Hake.
Thank you, Steve. If we go to the next slide. Steve, impressive knowledge on these projects. Thank you for doing that. While I'm talking very briefly, if any of you have questions for Steve or Don, put them into the chat. We have a lot of the scientists that Steve and Don mentioned online right now. And thank you, Don. You lead a tremendous program in the Southeast. I know you put a huge effort in making sure growers get maximum value for their dollars. The pandemic has put a lot of stress on the U.S., but finally, we're seeing some positive, some light at the end of the tunnel. And I just wanted to mention that that's due to three things. One, the scientists have really stepped up to the plate, but also the delivery, healthcare workers, and the population as a whole in trying to suppress the pandemic. You know, cotton is just a small microcosm of that. We have scientists, and we have extension, and we have farmers. And the Cotton Incorporated role is actually one of the smallest roles in there, even though you can see we've got a lot of projects, a lot of cooperatives we're supported across the U.S., a lot of institutions. It's really the land grant institutions, the Auburn, University of Georgia, University of Florida, all the USDA stations that do the heavy lifting. If you look at these numbers here, this only represents on average about $25,000 to $30,000 per cooperator, writing checks in 2020 for about $10 million. And that's about 10 cents on the dollar. So it's the support that you get from your land grant institutions in both extension and research and from the USDA that really make this program addressing about 50 different problems. You know, and virus is just one of those across the U.S. And with that, I'll be online here. Let me hand it over to Monty to coordinate some questions. Please give us questions.